In this part, we're going to talk about sets of numbers. Now, we've talked about some sets of numbers already, but we'll start with the counting numbers, or they're also called the natural numbers. Counting numbers. I'm just going to use the number symbol. And the counting numbers are 1, 2, 3, and so on, the way you count. The next set of numbers we usually learn about are called the whole numbers. And the only difference between the counting numbers and the whole numbers is we have 0. So 0, 1, 2, 3, and so on. All counting numbers are also whole numbers, okay? So here's the set of counting numbers, and the whole numbers include the counting numbers. All right, you're going to see my chart get kind of crazy here. Then we talked about integers. The integers are all the whole numbers and their opposites. So -3, -2, -1, 0, 1, 2, 3, and it extends in both directions. A lot of times I think of the number line and the numbers that we are usually writing on that number line. Okay, all whole numbers are integers, so all the whole numbers are also included in the set of integers. Well, then we started talking about decimals and fractions. So they make up, well, I got to be careful here, but our next set of numbers called the rational numbers. Rational numbers are any numbers that can be put in the form of P over Q, where P and Q are integers. That's the definition. So, another way to explain it is, it's what I usually do is I kind of list the 3 cases. It's all fractions. So improper, and I probably shouldn't write it that way, but all fractions where P and Q are integers, okay? So it could be a mixed number. You could change it to an improper fraction. That would be fine. Or proper fractions, those are fine. It's decimals that terminate. So the kind of decimals, that we've been working with, 5.2, that's a terminating decimal. It stops. That's what we mean by terminate. And it also includes repeating decimals. Now, we haven't seen those because we usually write them as fractions. But you've done that before on a calculator. 1 divided by 3 is, 0.3333, right? You've seen that on your calculator before. So any decimal that repeats can be made into a fraction. We're not going to go through that process, but it can be done. So all repeating decimals are also included in this set. These are all rational numbers. All integers are rational numbers. So all of those included in there. Okay, now you might say, well, what else is there? There are irrational numbers. Okay, so over here, we're going to make a set called irrational numbers. Irrational numbers. Now, I can't give you a list of them, but it's anything that's not rational. So it's any number that's not rational. See, I should say any real number, but any number that's not rational. And I can give you some examples. Like pi. Pi is irrational. It's a decimal that goes on and on and on, and it doesn't repeat. So that's probably one of our more famous irrational numbers. It's also things like the square root of 7. So that 7 is not a perfect square. In the last video, we talked about perfect squares. But if I wanted to take the square root of 7, there's a value. I can put it in my calculator. It'll give me a decimal approximation. But the decimal goes on and on and on, and it doesn't repeat. So they're decimals, or maybe we can say decimals that don't terminate and don't repeat. Okay, now those are a different set of numbers, the irrationals. You're either a rational number or you're an irrational number. You can't be both, okay? So if you're a rational number, great, you're in the set on the left. If you're an irrational number, great, but you're not in with the rational numbers, okay? All these sets together, if you take all the rational numbers plus all the irrational numbers, they make up the set of what we call real numbers. So real numbers include all the rationals and the irrationals. And so we're going to be working with the set of real numbers. And that's going to do us wonderfully well. Are there other numbers that aren't real? Yeah, but not this semester, so we're not going to talk about that. Not right now. So next semester we'll learn more about other sets of numbers. But right now we're going to stick with the real numbers, and so that includes all rational numbers and irrational numbers. Okay, so they want us to be a little familiar with these ideas, and so they give us a set of numbers, and they say, given the numbers, and here are our numbers, -3, negative square root of 2, 0.3, 9/5, 4, and the square root of 49. And it wants us to list the, okay, first we're going to do the whole numbers. Okay, so remember whole numbers, 0, 1, 2, 3, 4, okay, and so forth. I said 4, didn't I? So 4 would be in the set of whole numbers. And there's another one. It's a tricky one, but it's the square root of 49. Because what is the square root of 49? 7. So I'm going to write it the way they have it in the list, but in my heart, I know that the square root of 49 equals 7, okay? So those are the whole numbers. Okay, so that's the answer to part A. I don't think there's any more in there. No, -3 because it's negative, so it's not a whole number. Okay, now integers. If you're asking about the square root of 2, well, first of all, it's negative, so it couldn't be a whole number. But the square root of 2 is not a perfect square. 2 is not a perfect square, so it's an irrational number. So, okay, now let's look for integers. Well, first of all the whole numbers are also integers, so it's going to include 4 and the square root of 49. And it's also going to include -3. And I think that does it for all the integers. So anything that's going to be a whole number or its opposite. Rational numbers. Okay, a lot of rational numbers. So I'll just go through the list here. So -3, not negative square root of 2. That one's going to be irrational because it goes on and on and on. You can put the square root of 2 in your calculator and it's going to be like 1.4 blah, 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 blah. And it won't repeat. It won't be a repeating decimal. Even my dollar calculator does square roots. Okay, so negative square root of 3, not negative square root of 2, or -3. Okay, not negative square root of 2. 0.3, that's a rational number. It's a terminating decimal. It stops, but it's part of the rational numbers. 9/5, that's a good old fraction. That one works. 4, that works. Square root of 49, that works. Okay, all of those are rational numbers. The irrational numbers, well, there was just that one, negative square root 2. So that was the only one that was irrational in our list. And finally, the real numbers, well, it's all of them. So -3, negative square root 2, 0.3, 9/5, 4, and square root of 49. Okay,